Excellent. Well, good morning, afternoon, evening, folks. Welcome to Enablement session number one on February 23rd. Today we have Scott Henson talking to us about Terraform integration in GitLab, I believe, correct?
Yeah.
Awesome. Thanks. Take it away, Scott.
Yeah. So so GitLab can handle can store your Terraform backend. So you can essentially use GitLab as your Terraform state files, I should say. So you can use GitLab as a Terraform backend. So you don't have to worry about offloading any of your state files to Terraform Cloud or S3 or any other kind of storage domain. And so what we're going to walk through is just the functionality within GitLab that does that. There's also some Terraform helpers that GitLab has put out there, and there's documentation on that. I'll pull that up, and we can walk through it real quick. It's super simple. Essentially, it's every Terraform command you can think of with a GitLab dash in front of it. And by default, just the way that it works in a pipeline is Terraform inits are inherited, so you don't ever have to call a Terraform init. And that's purposeful because you're pulling it from the repository. So some of the files that are created via Terraform init command are going to be there based on what you have marked in your repository to be actually committed or not committed. But it runs a Terraform commit or Terraform init just to verify everything is there. So it's kind of a redundancy of commands to run that. We'll go through it here in just a second. Let me get this project up here. There we go. Share my screen. Okay, can you see my project here?
Yes.
Okay. So this project is a very just straightforward. It's a Lambda function, and it's deploying all the requirements to deploy a Lambda function and essentially give it a response. This one is super straightforward. All it's going to do is come up with a random number between 1 and 6, and it's going to say your dice are resulted in, right? And every time you refresh it, you'll get a new number. Not a huge deal. It's just enough to make Lambda function. And so kind of going through here real quick, I broke this down into 2 chunks of Terraform, and I did it because the S3 bucket that holds the Lambda function, right? We want it to maintain regardless of what branch you're on. And so I don't want to include that in my application Terraform, because if I do that, then if I tear it down for a feature branch, then I tear down the S3 bucket as well, right? And that's where production theoretically could be running. So instead I have a common bucket. That's where this Terraform common comes into play. And again, super straightforward. This is just my connection. This is the back end is HTTP. And GitLab will interpret that as local essentially to the repository. And then my environments file essentially has what I'm doing, right? This is the module. Am I doing a force destroy? What the name is. And then here's the actual common infrastructure. Right now, it's only an S3 bucket, creating an S3 bucket, and that's it. And then I'll use this for follow-on application changes as necessary for the Lambda function. And then in Terraform itself, this can literally be anything you want it to be. But because I'm using a Lambda function, I've got API gateway. This S3 bucket doesn't exist anymore, so that can be ignored. I have Route 53 in place and some variables of that nature. And then all the variables as well, they're already preset. If I go to my environments file I created here, you can see these are pulling var app version. It's pulling these from the GitLab CI YAML. Anything named TF underscore is going to be interpreted. So I'm pulling these in as TF underscore app version, TF underscore domain prefix, and TF underscore S3 bucket. We'll see that here in just a second. And then in my GitLab CI YAML, I have it broken out into a few different YAMLs just so my brain can wrap my head around it and I don't have 1,000 lines in one file. This is kind of a common workflow here. Essentially, it just makes sure that you don't run merge requests and branch pipelines at the same time. I'm including the application, including the authentication. This is the Terraform for the application, and this is Terraform common. This only runs if this flag is set to true. This is a CI/CD variable in the project. And that's more along the lines of if you were running this in real life, that variable would only be editable by maintainers and above. And so you want to make sure that like this isn't just sitting inside the variables here, because then you have the capability to destroy or override buckets right from a feature branch, and we don't want to or even on a commit inadvertently to the default branch. In real application, I would say your commons would sit inside of its own project, right? Inside of a group, but being that this is in my own private space, groups are impossible. So I threw it all in the same project and just broke it down into two different Terraforms from that perspective. But you can see here where I have like domain prefix, app version, S3 bucket, right? TFR, S3 bucket, whatever. And it will consume those as variables inside of Terraform. That's just based on the way that Terraform works. Kind of walk through this real quick. I'm using cache to cache my Terraform directory just so I have that available to all the downstream jobs. So it's not having to do everything in whole every time, but also to ensure that I have the same data from job to job when I'm trying to deploy these pieces. The other YAML pieces here, this is my application. Essentially, I'm just packaging this thing up in a zip file, and I'm putting it in this path, and that's it, right? I could, theoretically, I could upload this to S3 on my own from here, but that doesn't maintain the state of what's actually deployed. And so it's kind of, if this is a large application, then it would be go ahead and upload this to S3 or what have you directly. Doing it through Terraform is going to be a little bit slower, but being that it's one zip file, and as you saw, it's very small, I'm going to allow Terraform to do it just so I don't have to manage it, and I can just put it all together as I want. And then the authentication, I'm using the OIDC token within for GitLab and AWS. So I've created it where this project can do whatever it needs to, and with certain controls inside of AWS, and I'm just pulling that out and putting it into a specific place, and it's also being cached. So I can show you that cache here in just a second, but essentially it's caching those credentials, so downstream jobs can leverage that as well. You could theoretically also package them as artifacts and pass them along. The problem with packaging them as artifacts is artifacts can be viewed directly, and the cache cannot. All right, you can't go to the cache directory; it's all encrypted, so you can't just download the cache from there. You could create a job that exposes it and all that, but then that would be pretty obvious of what's going on. And like I said, Terraform common is just doing a plan, an apply, and a destroy. It's just extending jobs that I have actually in the other CIEM we'll look at here in just a second. And then I'm setting the environments for this as well. So this is just production/common. And when it stops, if we stop it or we run the destroy command, it stops it and puts it to a stop state from an environment perspective for GitLab. And then in here, again, these are my templated jobs, essentially. We'll look at this in just a second. This is kind of where the magic happens, but it's the same exact thing that's happening down here. I'm planning for the application, right? It's a review app, so it's ephemeral, and it's going to a dynamic endpoint. And we can look at that once it runs. But this is the review app plan. This is the production plan. This is deploying the review app, deploying to production, and then also destroying the review app and destroying production if that's what you want to do. In real life, you would have controls around these based on your environment, and certain people can, deploy to environments and click those buttons and need approval and all that kind of stuff. It's in my personal project, so I didn't want to have to bother somebody to say, hey, I'm going to put you on here as an approver. Can you please click this button? So I can kind of do everything here, not best practices, but just for the demos piece of this, that it's functional. So getting into the Terraform plan, essentially, before I do that, I want to make sure we understand the caching mechanism here. So the caching here is going to cache this Terraform /.terraform directory, and it's also going to be this AWS config path, right? This AWS config path is being set here based on what we need to do, because when you run it in pipelines, your root directory where your AWS config would normally sit is not going to be available to pass down via cache. So you have to kind of play the game a little bit. And so that's what I did for the authentication, is I put in a specific place, and then I tell it that my config path and config files or whatever are in a different path than the default. And that allows me to use the cache here. That's what this is here. And the key is based on the ref slug. So anything that's created like on a feature branch is only going to be available to that feature branch. Same thing with you know, the default branch or what have you. It's only going to be available to whatever the branch is, or the ref slug, I should say. It'd be the same thing for tags. But that's kind of the caching mechanism there. So if we look into these templated jobs here, I'm changing directory to TF root, and I have TF root set in my variables here, right? So here's the TF root. It's just Terraform. That's what it is in my code. So that's what I have set. This would be based on what you are going to use. My Terraform state name is default. And that's just the default state name. It's going to change based on the branch and the features and all that. This image is the image that's being used. This is the GitLab org Terraform image. It's got everything already injected into it, so I don't have to install anything. And then this is just the AWS CLI image as well. And I'm just variabilizing all these so I can change them at the top level if I need to down the road. The rest of these are pretty straightforward. This is just the bucket name that's going to be created. This app version here can be whatever you want it to be. If you've ever worked with Lambda, you know that just uploading a new zip file into an S3 bucket, even if the contents of it have changed, you know, drastically, it's difficult from a Terraform perspective to make Lambda say, oh yeah, something magic has changed here, let's do it, right? So really it's got to be a version change, or you've got to do some other fun items. I didn't feel like playing with that in the Terraform at this point in time, so I'm just going to change versions whenever I need to make changes as kind of would be in the real world, right? Something changed and we're going to push a new patch version or what have you. All right, so let's go back to the actual what's happening here in Terraform, right? So this is changing directory to the TF root, whatever you have it set as. This is going to run a GitLab Terraform plan, which is going to give you your plan, right? Is going to output it to the screen so you can look at it in your output. This plan.json is a piece that comes from within the helpers for GitLab. It outputs a file, right, named plan.cache, and it puts it in the directory. This is just part of one of the helpers. Generally, you could just use this without a problem, and there's no big deal. Because I have two different Terraforms or Terraform state files that are going to come out of this, one's going to be for commons and one's going to be for my application, I need to move this to a location that is, or change the name of it essentially, to a name that is unique to each of those. So I'm just changing it to whatever the state name is. And then I'm adding it as an artifact, so that artifact, that file can get moved down as necessary from a caching perspective. But also, like I said, it's being cached. But so the plan.cache is kind of a misnomer. It's not really a cache, it's just a random file. But I am artifacting this because I want to output this. So this is going to give me a Terraform report here. And this is going to say, based on, you know, whatever it is, it's going to give me the number of changes, additions, deletions, all that kind of stuff. So in a merge request, it's extremely useful because you can compare those things. And we'll look at what that looks like here in just a second. The Terraform apply, again, pretty straightforward. I'm just going to change directories to my root, and I'm going to move this file back because, again, this isn't the default name, so it's not going to look for this. I could pass the file names as I want to with apply and all that, but it was just to standardize it across the board. It made it easier just to change the file name essentially, and then do a Terraform apply. So this is just GitLab Terraform apply. Again, it runs the whole gamut of things because there is a file associated to it, and by default, GitLab Terraform looks for these plan files. This apply doesn't need to have a force, or it doesn't need to have you know, any approval associated to it, or to pass a file. You could if you want to, but it's not required if you have the plan.cache file that came from this plan JSON. And then there is, of course, the Terraform destroy, which is the same exact thing. GitLab Terraform destroy. It does the same thing as Terraform destroy. Before we move on, any questions?
I have something related to the GitLab Terraform image. Do you know if this gets like regularly standard updated with Terraform packages?
It does. And I can find that image, but also there are a lot of customer contributions that come from it as well. So whenever there's like a version change or whatever, people are, I've seen it quite a bit. It's like, hey, there is this new functionality in this version. Can we please do whatever, right? And they put a merge request in to update the version. But there's a lot of pieces there. That image has been very reliable for me in the past. But again, if it's not exactly what you need, right, you have the capability to do other things, right? You can build your own image as you see fit. But you're gonna get, it's from what I've seen, it's in line with what you get if you pull just a random Terraform image, right? That's what you're gonna get, all the tested pieces and all the tested packages. You're not gonna get anything that's like tip of the spear cutting edge.
Yeah, okay.
Go ahead. What was that?
Yeah, all good. Thanks.
And then these are the Terraform helpers. And you can dig through the documentation here to see exactly what they're doing, right? But a Terraform apply, right? These show, is there an implicit init? For the vast majority, there is. For a format, there's not, but that's not required either. But you can go through and look and see exactly what is there. So again, here's generic variables that are already open to you. And then there are the managed state variables. If you want to use these, you can use these for whatever you need in Terraform. I didn't put all of these in there because I wasn't going to build functionality just to demonstrate things that were not useful to my application. But you can also, if you don't want to do the implicit init, you can set this to false, things of that nature, right? There's a lot of things here that you can go through and dig through. Here's more items about the image here if you want to look it up. But you can, again, it's all documented pretty well. It's just a matter of kind of putting all the pieces together. So we've got all of those in place. Like I said, I'm deploying a review app. Essentially what it's doing is just creating a file in the same S3 bucket under that same version or whatever version is passed. And then it's just a dynamic URL. If you look at the deploy review app, you'll see that this is a dynamic URL that's going to be associated. Happy.tanuki or happytanuki.click is just a domain that I have access to. And so that's where it's setting. And then I also have it set to auto stop. So if it's running for more than an hour, it automatically just runs the stop, which that stop is this destroy review app, which essentially does a Terraform destroy, and it stops the environment within GitLab. So everything shows as shut down. Let's look and see. I think these pipelines are cleaned up now. I've been playing with this quite a bit. Yeah, everything's been destroyed. Oh, this one's not. So that's fine. This is common infrastructure. That's, like I said, just the S3 bucket. We'll go ahead and leave that for now. I am going to change the CSU variable so it doesn't keep trying to deploy it, or it's just going to run Terraform on it and go, oh, nothing changed. So you see I have this variable set here for deploy commons, and right now set to true. You can set it to false. You can set it whatever you want. It's only looking for true. It has to be true for it to run. Otherwise it does nothing. I'll leave it here for now for the first time. But if I look at my pipelines here, I've got these broken out and they're kind of heavy-handed and very large purposefully. And that's just to kind of demonstrate everything that's going through in each stage. This could be cleaned up and streamlined quite a bit, but that's not really what I want to show is, how you can mash all these things together. I want to show kind of the functionality of it. So like I said, this is pretty wide for what we're doing here, but this is packaging the application, just creating that zip file. This is assuming that role. It's only good for an hour. So if you don't run it within an hour, you've got to rerun this assume role, and that's why it's set as a manual job. So you essentially don't run it until you're ready to deploy. This is playing the common infrastructure. That's that S3 bucket for now. That's going to deploy it. This is going to plan for production. This is going to deploy to production, right? And then I can destroy production and destroy my common infrastructure. Right now, destruction is, or production's been destroyed, right? But common infrastructure hasn't. So if I look at my environments here, production common is the only one that's here. The other two are stopped, right? One of them is going to be production, and the other one is a review app that I've got deployed right now, but it's again in a stop state. And then if I look at my Terraform state files, here's the state files associated to those. So like here's feature A, which is it's currently there. It's just in a stop state. My default, which is my application, and default common. Again, you can change the naming convention based on needs. Let me go to pipelines here. And I have this pipeline here for feature A that is done, and it has been destroyed. Okay, good. So we'll run a new pipeline. So this is a new application. We're just getting up and running. So our first, main commit is going to be, or commit is going to be to the default branch, just to kind of initialize everything. So let me just run that pipeline and we will get that started. I could override that variable here for deploy commons, but I'm just going to let it go for now. While this is running, there's a few manual steps I have to click on here. Are there any questions from what we've spoke about so far?
Another one for me. So the common infrastructure you're deploying, can I consider this like as a dev environment? So dev deploy an S3 and test, and then you do the manual process of production deployment when you merge to prod, or like
So yeah, we'll go through that in
Yeah.
just a second, right? This commons is not always going to be included. This is just an S3 bucket, right? This essentially is creating this bucket here, and that's it. So you see there's nothing in this bucket. It's just the bucket just got created. And that's essentially because all of the zip files are going to go to the same bucket regardless of the environment, right? You may have a production bucket, you may have a whatever. I have one bucket, and essentially it's all going to be based on the version. I'll show you that here in just a second. And we'll make changes and push those changes. But that commons is only to deploy that bucket that's going to be used across different environments, essentially. So I don't want one environment to deploy a bucket, because if it does that, then my production environment would be, if say I take down my ephemeral environment, right, and I run a Terraform destroy on it, and that bucket was part of that, then that bucket goes away, and my production environment could be part of that bucket, right? So essentially, it's like I said, this theoretically would be in a different project, right? But I just threw it all in the same one. So it gives the capability to leverage the same bucket, and you'll see there's actually a file structure that's going to come out based on the version. And once we start deploying things, you'll see those pieces here. So this is the assume role piece here. If you've not played with the connectivity between AWS and GitLab, it makes things extremely nice. Again, best practices wouldn't be to use the same role across everything, because theoretically I could just make a role that doesn't have the ability to create or delete buckets, right? And that would be the role that all other branches besides my default branch or whatever the branch is deploying to production, right, doesn't have that role. The only role that would have that is the role that can deploy to production or whatever, or a separate role by itself just to isolate it. But this role essentially has the ability to create S3 buckets, and it can list and essentially everything with S3, the Lambda function piece of it, the everything that's needed essentially to deploy your Lambda function. So this assume role here, while this is running, let's just take a look at this. This is kind of a bonus, not necessarily for Terraform, but it's just a bonus here, right? So essentially it pulls everything down. It makes the call to AWS and gets the credentials as needed. And then I'm just doing a get caller identity here. And so this tells me this is a user ID, here's the account, here's the AR, right? And so these are all uploaded as necessary. I'm just getting the caller identity here because you have to have a script in a job. And that's essentially where that's happening. So I'm just getting that caller identity. We can look at that more if you're interested and you have time. So like I said, this is just planning the common infrastructure. It's good running a GitLab Terraform plan. There's gonna be no changes here. So it's really gonna output nothing. Because there's, like I said, no changes in this plan. So as you can see, it ran a GitLab Terraform plan. It initialized everything because a init is inherited. And here's the modules. There's no changes, right? So it's going to go ahead and move on. And then it's going to do the plan JSON to get the cache file. But there's nothing to be changed. So it's just going to pass it over. And then this would be deploying the common infrastructure. Again, it's creating an S3 bucket. It already exists. So it's going to say no changes and it's going to move along as well. And let me show you over here under the environment. So when you stop an environment, especially an ephemeral environment, it will stay here. So this one is just for my feature A branch, right? But if I had a feature B branch or a feature whatever, or bug fix, it would be here. And once it's stopped, even though everything's been deployed or everything's been destroyed, this would stay here. So that's one item that would need to be cleaned up. You can clean it up via an API call, or you can clean it up in the UI. There isn't a inherited function inside of GitLab CI that just says and delete the environment. That it's not part of the functionality. You would have to do it via the API call. Then also we already looked at the state files here. Yeah, so I've deployed these before, right? And you can see when they got deployed. And then this one is there's no update to it, so it's not going to change anything. You can delete these, you can download these. It's actually super useful if you're going to be working on your local machine and you want to be able to test out your Terraform locally prior to any push into a pipeline. You can get this Terraform init command right here with your access token, and essentially allows you to run all of this from your local machine as well. So you don't have to try to square peg round hole it too much, right? It gives you a lot of the information, and this will set you up from the init perspective to work locally with Terraform or with GitLab as your Terraform backend. All right, let's see where this is at. All right, so this is the plan. I can take that plan off. It doesn't need to be manual. I don't know. I got that manual. We can fix that. But while this is running and deploying, I'm going to go back to so in this feature branch, I made a couple changes here. That's not what branch. I made a change to the application, right? So essentially I had a date in there that I took out that just says and was issued at now, and put where it's just random number. So I'm going to edit this, and I'm going to redeploy this feature, and then I'm going to open up an emerge request and I'll show you what happens there. Okay. All right, so we're going to see another pipeline kickoff here. And this is going to be for my feature branch. Let me go ahead and deploy this to production. This is going to be for the feature branch here, right? And this obviously has a lot less stages in it because it's just doing a plan and a deploy. It's not worrying about the common files. It expects that S3 bucket to be there. If it's not there, of course, it's going to fail. It has nowhere to write the S3 or write the zip files to. So it would fail. But this is going to essentially deploy this. Well, the deploy on the branch side is manual, right? And that's just the way I have it set, is so if you do a commit, then you may not want to deploy it to the environment, right? You may be working on other things and just trying to make sure that the plan is functioning or what have you. And you can manually deploy it via this branch. But I'm going to open up a merge request once this is done, and we can kind of see what functionality happens there. And I'm not using any special runners here. I didn't actually specify any runners. I'm running just the ones that are offered by GitLab. So you can see this is running a Terraform apply here, and it's running in a init as it does. And then it's creating all these resources, right? So there's an IAM role that is going to be created, API gateway, the object's being uploaded. If we go look at this bucket here and I refresh it, you'll see now there's a version here, right? That's the version that got passed. And then inside of this, app.zip is just what I've named my one for my application that's deployed to production. When we deploy it into like a feature branch, you'll see that there'll be another file here that is named differently. Let me just make sure. And there's Route 53 records that are being injected and API gateway stuff and everything else. So I'm not gonna bore you with that unless you are super interested in requirements for a Lambda function.
Ass.
Yeah, it's a fun process if you've never been through it. There can be a lot of gotchas depending on your application. So again, this is going to deploy it to this for feature A, and so there'll be a different URL at the end of the pipeline. It's going to output your URL. Just have that as being returned. We'll see that here in just a second. So this has to create Route 53 records, and because it's creating Route 53 records, there's a wait essentially that's built into the Terraform I have that says wait till this becomes available. So it's looking for that record to come up to say yes, okay, it's reachable now, before it does anything else. So right here you can see for the serverless app, this is the API gateway base URL. So if I look at this, I can open this up in a new tab, and this is going to say your dice throw resulted in a 4, right? I can refresh it all day long and it just gives me a different number. But also this is my actual application URL or URL, right? If I was actually like running an application, this is where I would go and check out that application, because this is just a simple returning a message, right? This is all you're going to get, the same exact thing. It just has Route 53 in front of it, so you have an endpoint. Any of y'all can go to this endpoint right now and do the same exact thing and get a random throw of a dice. Hey, let's go back here. Let's see where this one is. Just a second. But you'll see here in this bucket, there's app.zip, right? So now if I look at this, there's a feature A.zip. That's that feature branch. So that's essentially the Lambda functions, and you're looking for that based on the needs of that. If I go to Route 53, you're going to see that there's Route 53 entries that got put in, right? Again, that's all Lambda stuff that we can dig into if necessary. But here we go. So this is again, same thing. Now this is showing, oh, we got a 2 and was issued at, right, and gives us a date. Cool, super cool update, whatever it may be. And it gives me this ephemeral URL as well. This gets created, I should say dynamic URL. This gets created on the fly based on what's necessary for your application. It's using the branch name as a naming convention to get that URL running. You can tie it back however you want. But now that we have that change in place, let me open up a merge request here. I'm gonna go from branch A to main. Yeah, I'm not gonna really put anything in here because I'm not super worried about it right now. Okay, so a merge request pipeline is gonna run for this as well. On the merge request pipeline, it's going to essentially redeploy this application. If you open a merge request when you open the branch, then it's not gonna rerun that pipeline. It really is dependent on your application and how your team works. But this is going to run a merge request. If I push a commit to the branch, it's not going to run a branch pipeline. It's just going to rerun this merge request pipeline and update it. So if I see there's an error or something that may be there, that's going to show up. Because this is a review app, it sees that based on naming conventions. I can just click on review app, right, and it goes to that endpoint, so you can preview it however you see fit. But once this runs, we're going to have some output here from our Terraform plan. I have it set to actually run the plan for production as well. So you can compare the two to make sure that the changes are associated between those two items. And you're not making 5,000 changes to production that are unintended. We'll look at that once it gets to that point. And then also this merge request won't allow you to, because I have it set that pipelines must succeed. This will not let you merge it until you actually stop the review app, which means that it actually tears down the environment, right? So it does a Terraform destroy on the ephemeral environment. Let me go in here. I want to make one more change just so we can run that pipeline as a merge request pipeline again. This is going to be in my GitLab CI YAML. And this is just to update the Terraform. I'm going to edit this directly. Shouldn't really be doing this, but whatever. I'm in the wrong branch. That would have been bad news, huh? All right, there we go. And so I'm going to change this to 1.0.2. We made some minor tweak, right? All right, let's go ahead and change that. All right. So if I go look at pipelines here, all right, this one's still running from that previous merge request because it's deploying. If this was sitting in deploy and this got to deploy, I have resource groups identified, so it's not going to allow that deploy to happen at the same time, right? Only one of those is going to run. So this one will have to complete before this next one would pick it up. Is essentially how that works. I'm leveraging the resource groups. I don't know if you saw that inside the YAML. Let me show you here. There we go. If you look like this, I've got this resource group right here, right? So actually, I didn't set it up for review app. So just kidding, for review app, that wouldn't happen. For production, that does happen. So there's a resource group here. So if there are multiple merge requests that go to production fairly quickly, which essentially is commits to that branch, it's not going to allow these to run concurrently. It's gonna, one has to complete before the next one would run. And so if you do that for your plan and for your deploy, and even for your destroy, it can ensure that your environment essentially is not being overwritten by another commit that comes to that branch. Let's see where we're at. Okay. But now you can see I've got 3 environments that are running here. This one's production, right? And I can click open and it's going to go to the URL there and you can see what it currently looks like. And then I can go to feature A and you can see what it currently looks like from our change. And then I'm just waiting for this merge request to finish deploying, which is going to should be fairly quick because there's not much that needs to be changed.
This is really great. I liked it a lot that you combine it with environments and cache, because the standard Terraform templates, I think GitLab provides,
They're
the
they're being
there
deprecated,
is
actually, Aaron. That's a good point.
yeah,
They're deprecating them because they're minimal as intended, but they're super minimal, right? They don't really get you very far by using those templates.
yeah, exactly. So you have, for example, destroy as the manual step at the end, etc. So I really like that you combine this with environment destroy, which with like the moment you stop the environment, that it does the destroy, for example, for the future branch.
Yeah, so I can destroy here. I can go back to the pipeline and click destroy. I can click the stop button here. I can go to the environment and click the stop button. It's all the same functionality. But you can see right here, there's 2 Terraform reports are generated by your pipeline. And this one is for my review app, right? And it's saying, okay, one thing was added, one thing was changed, one thing to delete, whatever that may be. You can go to the full log here, and that's going to send you back to this essentially, right? Back to the log, and you can look at the things that were changed. And then this is saying, okay, from this, these are the changes that are going to be going to production, right? And so you, again, you can go back and look at the full log here, and you can look at the changes that are associated to because this is running just a Terraform plan. This isn't running anything else, but you can see what's gonna change in the environment, right? So essentially you can see that I'm going from 1.0.1 to 1.0.2, right? It's changing that version there. So if I look in my bucket here now, right, I only have app.zip here in 1.0.1 and 1.0.2, right? The feature A is moved over to there because it's changed that version there. So it kind of gives you the ability to track. If you wanted to maintain these zip files long term, then my real suggestion would be to leverage the uploading inside of your pipeline as opposed to inside of Terraform, right? Because Terraform is either going to add it or delete it. It's not going to ignore it. So you can look at those changes there, but that gives you a quick look here that says, hey, here's the additions, changes, and deletions that are going to happen. And it says pipeline must succeed, so I can't even merge it in until I kill this environment. So I can just stop the environment here. That's going to run that last stage on the pipeline here, which is going to destroy that review app. And I'm just going to set this to auto merge so it kicks off after the fact. And then we'll see all that update kind of trickle down because the merge request will be accepted, and then essentially that's changes get committed to the default branch, which is the branch that deploys to production. And then if I look at my environments here, let me refresh this. So I've told this to stop. You can see how this is showing auto stop in 57 minutes, right? Because I have that set up. So if you open up a merge request and nobody looks at it, then within an hour, it's going to take that environment down because it costs money. And you can go back and redeploy it through the pipeline or what have you. This shows you where it was last done. So you can actually click on this and rerun it. You can go back to your merge request and rerun the pipeline. There's a million ways to redeploy the environment. But this is showing as there is no stop button here because it's in a stopping state. So it doesn't go to stopped until it's actually stopped. That's why it's still showing as active, because you can't stop it, but also at the same time, it's not stopped. So it's kind of in a weird interim state. And once that pipeline is done here, destroying all the resources, and again, it shows you everything it's going to destroy. Then it'll merge that piece in. That environment will go to stop, and it'll show in this tab here. And then again, if you don't need it anymore, you can just delete it. Because that's one thing I was going to add in, but I didn't get around to it, was making the API call on destroy to actually just delete the environment too, because this is no longer needed, right? Even if it's in a stop state, you're going to end up having 1,000 environments here that show up. So just for cleanliness, it would be one of those things you'd want to clean up over time. Any questions so far? We're getting towards the end here.
Is there any way to automate the deployment via the report results? So are there like numbers of added resources from the Terraform plan? Is there any way to automate like how many reviewers it needs or stuff like that based on
Like
the
approvals and
Terraform
stuff like
plan?
that.
Yeah, exactly.
Yeah, so you can, because this is in my own personal namespace, right? I don't have a whole bunch of other groups. So this got merged, right? That finished, so this is merging. But you can have merge request approvals on here, right? So you can say, I can create a feature branch all day long and I can open up a merge request against it so that we can review it, right? But I need at least somebody from my QA team and I need somebody from, I need my manager to also agree on it, right? And you put a merge request approval in there. So this merge wouldn't happen until those two at least, and you can have as many merge request approval requirements as you need, but this wouldn't happen until that merge request approval goes through. And then once it does go through, it'll deploy. Or are you talking about manual deployments to ephemeral environments?
No, I'm talking about can you set the reviewers based on the changes made in the Terraform? So the Terraform plan spits out one to delete. So can I put some reviewers on it, like based on the reports generated in the pipeline? So if something is getting deleted, that's maybe an resource we need. So maybe need some reviewers, but if there are some addings only, we don't need additional reviewers.
I don't think that functionality exists. Glenn or Aaron, do you know? I don't think you can say based on this finding. I think it's either there's approvers or not. I know that you can throw certain flags to include approval groups based on environments or what have you, or necessary groups, but I don't think it can be done based on the output of the reports.
Yeah, not that I know, but if I understand correctly, if I'm deleting X, make this person review it, or if I'm deleting just in general, make this person review. Otherwise, they don't need to. I don't think there's anything like that. But the closest you could get, kind of what Scott was talking about, would probably be something around code owners, where you could say,
yeah,
this specific module, if something changes here, make sure this person knows. But that's about it.
That was my next suggestion, is code owners, right? You can have your storage team, right? They're the ones that are code owners of anything that's in that storage module. And if something changes there, they get notified.
All right. Yeah.
We do not have, I think, such functionality also for other things like JUnit tests or whatsoever, that there is a, okay, something failed at another approver. Maybe via API you can do something, but like a workaround.
Yeah, you would have to like leverage custom attributes and have that checked in the pipeline that, if this is there, then this custom attribute, there's a lot of things you can do there, but that's not natively built in as a function you can just use, right? You'd have to build all those. It's just like the same thing. You could actually, I mean, if you wanted to, you could take the output, put it into a certain format and actually export it as like a vulnerability and have that type of vulnerability set to a certain team, right? So it really looks like a security vulnerability than anything else. But it would then automatically trigger an approval from that group. But that's kind of a workaround that I wouldn't suggest, because now you're injecting security vulnerabilities that aren't actually security vulnerabilities. But the code owners piece is really the piece that needs to be known, because it's going to be the changing and deletion, right? And they're the ones that would need to be notified of it. So it would have to be changed in that module. Actually, that's a good point, because it really could be changed via a variable as well, and that wouldn't change the code in that module. So that would catch like actual like code changes, but from like I'm changing the name of my bucket, really that would be more of an approval that would need to be set as a merge request approval, right? Has your infrastructure team looked at this? Yeah, that's a good question though. It doesn't go, it's kind of approve the merge request or don't approve the merge request. It's not really based on what changes are happening in Terraform. It really is only going to be based on what changes are happening in the code.
Yeah.
So this is deploying the production pipeline right now. And it's oh, I forgot to set that flag again. So theoretically, I would have set that to false, right? So you don't have to worry about that bucket ever being looked at again until you actually need to change it or delete it. but that's currently running, and then it'll do the plan and create and deploy and all of that fun jazz. If I go back to environments, yeah, it's updated, right? So it's showing it stopped now. So this branch no longer exists. So I would like to make an API call, right? That says delete this environment. But it's not there. So I'm going to make the API call with my finger and click the button. And that'll just get rid of that environment there. So again, it's no longer there. And if you wanted to clean up these environments, it'd be the same thing. So like here's production, right? This is currently waiting for destroy. This is from a previous run. So this got deployed, and it says it's waiting because the next step is to deploy the infrastructure or to destroy the infrastructure. But this is my latest deployment here. Let's see where we're at. Okay, let me go and run that. All right, I think you guys kind of see the purpose here. Any other thoughts or concerns or questions, or right about at time here, and I don't want to go over.
That was great. Thank you very much, Scott.
Yeah, it was great. Thank you. Is there any way this is published? Can we use
Yeah,
your
it's marked as
can we use the demo?
let me drop it in the chat here. I meant to do that at the beginning and I didn't. Yeah, it's public. There's a few things that are only if you're members of the project. It's in my own personal space. Glenn, I imagine we can probably find a place to put this. Maybe we need to create a new group or something that's associated to this call every week or every other week.
Yeah, I know we talked about that before. I think Leopard has a place. I'll have to ask him and see where we can stick this.
Okay, yeah, because we can just move it over there. But again, this is tied back to my AWS account. And so I've got controls on there unless you're a member, you can't really do anything. You can look at it, but you can't really do anything. Because I don't want it, all over the place.
Don't want a public project that's going to cost you $20,000 a month.
Yeah, so I mean, it's running on Lambda, right? So it's really not that bad, but I mean, you could deploy as many branches as you want to. All right, let me run this here. So one quick thing, right? You'll see here is I deleted that ephemeral environment, right? So the 1.0.2 went away because it's no longer there. Again, that's the problem with uploading to buckets via Terraform. Is if it's not there, it's not there, right? It's going to get rid of it. It's not going to let it linger. You could turn the force destroy off, but then you're going to run an error in Terraform. So once this uploads as well, you're going to see that this version is going to change. This folder will go away. The new folder will be 1.0.2, and you'll see that app directory in there as well. All right, that's going to deploy, then we'll be done. Yeah, so that's just going to upload to the S3 bucket and go from there. The vast majority of the pieces are already there, so it's going to look at it and go, oh, all of this is fine. And so it's just going to upload the file, make some minor changes within Lambda, and then it's going to be redeployed. If I can get this pipeline to go, we got 1 minute. Come on, pipeline. But yeah, this should be fairly quick. Yep, there we go. So it's already run. We just haven't gotten a report back from the runner. There we go. Already succeeded. So you can see it changed the folder and there it is. And then if I go look at my environments here, here's production. I can open this up. And now it's got that change that we pushed. All right, fun times. Woo. So thanks for everybody's time. I really appreciate it. Let me know if you have any questions or if you need more access to that project or what have you.
Awesome. Thanks again, Scott. Really appreciate it.
Yep, absolutely.
Take care all. Yep,
Thank
see y'all
you so
later.
much.
Bye.
Thanks, Scott. Bye-bye.